Okay, we're going to simplify. Number 1, this is not only Math 3 review, but you also learned this in Math 2. 36 to the 1/2. What is that equivalent to? Okay, how is it 6? I heard it means the square root of 36, which is 6. Do you have to show me that square root step? No, how many of you can just say, oh, that's a square root, the answer is 6? That's perfectly fine. You do not need that square root step. All right. 2, negative 25 to the 1/2, and I'm going to write 3 down with it, parentheses, negative 25 to the 1/2. And in this unit, we're only working with real solutions. We will not be dealing with imaginaries. So, which one of these has a solution and which one of these has no solution? 3 has no solution, no real solution. And why is that? Because it's in parentheses, which means that square root is applying to the 25 and the negative. Do you see that? This one, since it's not in parentheses, what is that square root being applied to? The 25 and the negative? Just the 25. And what is the square root of 25? Okay, so we have negative root 25, which ends up being negative 5. Do you see the difference between 2 and 3? All right, what about number 4? Is number 4 also no solution? It's parentheses, negative 64 raised to the 2/3. Does this one have a solution? No solution. I hear some yeses and nos. Let me rewrite it. I'm going to put the negative 64 inside. What goes here that I don't see? 3. What goes here that I don't see? Squared. All right. Where this one was the square root of negative 25. Do you agree? Now, what's the difference between a cube root and a square root? Can we take the square root of a negative? Can we take the cube root of a negative? So does this one have a solution? Yes. Anybody know what the cube root of negative 64 is? Negative 4. So it's negative 4 raised to what power? Squared, which ends up being 16. All right, so be careful with the negatives before you say, oh, no solution, no real solution. Make sure you're paying attention. Is it a square root, a cube root, a fourth root, a fifth root, and so forth?
The reason why for 4 it can be a solution is because it's cubed.
It's because this is odd. So cube roots, you can take the cube root of a negative, you can take the fifth root of a negative. Any odd root you can take of a negative. What is that?
No, it's just a big old fly.
Oh. All right. Make sense? All right, negative 64 to the 2/3. Now, is this pretty much the same as number 4? No, it's not. How is it different? Do those parentheses make a difference? Okay, so this 2/3 was applied to everything, including the negative, where this one's only applying to the 64. So what's that negative going to do? Sit outside until we're all done. It's going to be the opposite of whatever our final answer is. So we're going to take the cube root of 64 and square it, and then at the end we're going to take the opposite. What's the cube root of 64? 4, and 4 squared. So is it 16 or negative 16? Do you guys see the difference between the two? Kids will say, oh, well, you're squaring a negative. I'm not. I'm only squaring the 4. The negative was never part of the 2/3 power. All right, number 6. 2 to the 4th times 3 to the 12th, parentheses, to the 1/4 power. With our tools that we have choices. I can figure out what 2 to the 4th is. I can figure out what 3 to the 12th is, multiply those together and raise to the 1/4 power by hand, or I can distribute the exponent because it's multiplication. What's easier to do? Distribute the exponent is correct, because what is it going to do to the numbers? Because the exponent's a 1/4 power, it's going to break it down. Do you agree?
Yeah.
So it's going to end up being 2 to what power? 2 to the first, which is easier than 2 to the fourth. Not that 2 to the fourth is hard, but still less work. 3 to the what power? Third. Now 3 to the third is much easier to calculate than 3 to the 12th. Do you agree? All right, what's 2 to the first? Times 3 times 3 times 3 is, good job, and 2 times 27 is 54. All right, questions on any of the reviews so far? Am I going too fast? No? Does it feel like review, like, oh yeah, I've seen this before? All right. 0.01 raised to the 3 halves. All right. What is this going to do? The square root? Yes? Square root of 0.01 cubed. And without a calculator, how do we work that out? I'm going to cover everything. In elementary school, you learned that this is 1/10 or 1/100. That's in the hundredths place, correct? So the square root of 1/100 cubed is 0.01, the same as 1 over 100. And can we take the square root of 1 over 100? Okay, ignore the fraction. What's the square root of 100? So what's the square root of 1 over 100? And I'm going to raise it to what power? So it's 1 over, you're right, 1,000. Or if you want to change it to decimal form, you can. All right, I'm going to give you the next one to try on your own. Number 7, 8, lied, sorry, 8. 0.001 raised to the negative 2/3. Go ahead and try it. I know there's a negative, but at least try. Can anybody at least tell me how you rewrote this? 1 over 1,000? And what is the cube root of 1 over 1,000? Now, 1/10 to the negative second. What does a negative exponent do to the base? Flips it, so it becomes 10 to the positive second, which is 100. Anybody get that on their own, or at least very close? Good. So remember, negative exponents flip the base. We're good? Yes. What ends up happening, I'm going to rewrite it over here. It's 1 to the negative second over 10 to the negative second. And negative exponents move up or down. So this one would move down, and this one would move up. 10 squared over 1 squared is the same as 10 squared. Yeah? So if you have a fraction and it's raised to a negative exponent, what do you do with the fraction? Flip it and then raise it to the second or third, whatever power it may be. Okay, questions? Number 9, this is more review. This is also review that we did during the SFAC. Are we on 9 already? What was that? 6 to the 4/3 times 6 to the 2/3. All right, so this is going to be super quick review. What do we do with the powers when we're multiplying like bases?
You can add them.
You add them, but you do not multiply the bases. The bases stay the same. So it's 6 to what power? 6/3, which is equivalent to 6, which is equivalent to, I feel like I went too fast on that one. All right, so what do we do? Bases are the same. At the exponents, bases stay the same, so it stays 6. 4/3 plus 2/3 is 6/3. 6 divided by 3 is 2. Therefore, 6 squared is 36. All right, 7 to the 7/3 over 7 to the 1/3. Do we still add? Subtract. And the bases stay the same, so 7. If they're not common denominators, you will have an extra step, but right now they're common. What 7/3 take away 1/3? And so it's 7 to what power? Which is 49. All right. Now, what if you see it like number 11? I'm going to show you what number 11 looks like, and it looks weird, it looks different, but I'm hoping we can handle it. Are you ready? X raised to the square root of 2 divided by x raised to the square root of 18. Is correct. All right, first thing I'm going to do is write it as a fraction, just so it's the way we're used to seeing it. X to the root 2 over x to the root 18. All right, when it's written like this, what do we do with the exponents? Everyone agree we subtract them? All right, so I'm going to do that work over here. I have root 2 take away root 18. Can I combine radicals like this? Are they like terms? No. They are not. Austin, get your head up off the desk, please. What can we do? Does anybody know?
Oh, you could go to 2 1/2, 18.
Good job. She said we can break down the 18. Do you guys agree with her? Prime factors. What does 18 break down to? Did I hear 9 and 2? Okay, so he already gave it to us. That's root 2 minus 3 root 2. Do you guys agree? Yes or no? That root 2 stayed root 2, and he's saying root 18 is equivalent to 3 root 2. Do you guys agree with that? All right, so this is x2. What is 1 root 2 take away 3 root 2? Negative 2 root 2, and we don't leave it negative, so where does it move? Denominator. And what stays at the top if there's nothing else there? A 1. X raised to the 2 root 2, and that there is your final answer. All right. Do you have a pass?
What's your AdvMath name?
Number 12. 8 to the 1/2 over 2 squared. Now, I know you guys have seen this before, because I remember Chris telling me one time, oh, get them to the same base. Do you guys remember that? Yep. Yep. What would the same base be here? 2. So the denominator is going to stay 2 squared. Do we agree? And the top is going to be something to the 1/2. 8 is equivalent to what? 2 to the 3rd. And what do I do here with the power to a power? I multiply. And I did mess up, so please don't go too far, and I apologized, going too fast. This is not a 1/2, this is a 12. Sorry. Makes things a little easier for those of you that were working ahead. Please change it to a 12. All right, so it's still 2 squared at the bottom, something to the 12th power, and 8 becomes 2 to the 3rd. Do you guys agree? Okay, so now we know to multiply. I did say that earlier, so it's 2 to what power when I do multiply? Over 2 to the 2nd, and what do we do with the exponents? Subtract, so it becomes 2 to what power? And that we are not going to calculate. We're going to leave it like that. Questions in any of the review before I move on to the true-false? And the true-false, I could probably go really quick through as well, because this is review from the SBAC stuff that we were doing. All right, 2 to the 2x equals 4 to the x. Before we go any further, juniors, how was the SBAC?
Hard.
Was it hard?
The second part.
The day 2? What was that?
Nothing that was on there was on my version. Like nothing.
Not even that maximum problem?
Except like the 2x plus 3y. That stuff was on there, but none of the other stuff was on there.
It's tough.
It was tough. Did you guys try your hardest?
It took me 30 minutes on the question. I ended up skipping.
Yeah.
How about the day 2 performance task?
That was really hard.
That one was harder.
I could not do it. I guess.
Okay. There were less questions, but it was harder. It was weird. When the scores come back, O'Neill and I will look at them and see between the two. All right.
See, y'all gonna need a butter today.
Guys, shh, we're listening. All right, true or false? Those of you that were in my class, the seniors, there was one like this on the test, at least I remember, quiz or test. We have to do what first? Get them to the same base. So 2 to the 2x equals blank to the x. What is 4? 2 squared. And what do I do with the powers? So it's 2 to the, true or false? True.
I don't remember this.
Yeah, I don't remember.
It was either I'm pretty sure it was in the chart and it said true or false and it gave you a bunch of them and it gave you, okay, thank you. Was it, no.
Probably guess.
Quiz?
Oh, okay, it was somewhere.
We're never gonna see that.
That was a long time ago, I think.
We're never gonna see those.
When are we going to see these? In this unit. That's why we're reviewing it right now.
Test scores.
Oh, when are we going to see the test scores? Because I was out sick, I didn't even look at them. I'm not going to lie. They just got put away.
It's not test,
And
it's a quest. Remember
the
that.
quest. So I'm going to hopefully work on them this weekend.
Can we correct it, like, to the person sitting next to us can drink one?
Number 2,
Yeah, dude.
2 to the x
I got you.
plus 2 to the negative x
It's a false. No,
equals
I didn't.
2 plus 2 to the negative 1 raised to the x. They're pretty much asking you here properties, like is this a property we have where we can distribute this exponent and call that 2 to the x and distribute that, and that's 2 to the negative x. Do you guys agree if I were to distribute I would end up with this? Is it mathematically correct to distribute
Sure, yeah.
when there is a plus sign inside parentheses? No, you can only distribute exponents if that was a what?
Minus. Multiplication.
Multiplication or division.
Wait, 7?
You can only distribute exponents when it's multiplication or division. So something like this, 3x squared y z to the 3rd over x y to the 5th, big parentheses, 4th power. Something like that you can distribute.
Out of nowhere.
That's so simple. And they just,
So why did I make it so hard? Because I wanted to show you the multiplication. It doesn't matter how many terms, as long as it's all multiplication or division. Like that didn't have to be there. It could just be that. But once you throw a plus sign in there,
So it's false. I told you.
you can't.
you cannot distribute. It's not allowed. Okay, so once it's a binomial or larger, you're not allowed to distribute. So this would be what? False. Okay. So repeating, when can you distribute the exponent? When there's two things, multiplication or division. All right, 2 raised to the 3 plus 3x equals 8 raised to the 1 plus x. All right. Would you say this looks more like number 1 or more like number 2, or a combination of the two? More like number 1? 2 and a 4, 2 and an 8. Power. The powers look different, but it's still 1 base raised to a power, where this had 2 bases. Do you see the difference? All right. So can I try like number 1 to get them to the same base? Which one am I going to change? So blank raised to the 1 plus x. Change your 8 to what? 2 to the,
Third.
and what do we do with the power to a power? You multiply, which in this case is going to require distribute, which is what I heard you start to say. 2 raised to the what?
3 plus 3x.
True or false? True. All right, number 4 is going to go back to number 2's concept on when can you distribute. And I already told you guys you are allowed to distribute when it's a what in the middle here? Multiplication or division. All right, so what if I gave you something like this? 5 to the x times 4 to the x equals 20 to the x. Would that be true or false? So they're asking you this. 5 times 4 to the x. Do you guys agree that 5 times 4 is 20? So if I started off with this, could I distribute the exponents and call it 5 to the x and 4 to the x? Why am I allowed to do that? So, true or false? True. All right, so just getting used to when are you allowed to distribute, when are you not allowed to distribute? Yes.
Is that the only time you can multiply the bases?
Yes. Yes. Good question. He said, that is a really good question. Over here, did I multiply the bases? No, because the bases are the same, I did what to the exponents? Added them. Here, because the exponents are the same, I don't touch the exponents, but what do I do to the bases? Multiply them. All right, number...
So if the bases are different, but the exponents are the same, you just multiply the bases?
Yes, and the exponent stays. All right, so her question was, if the bases are different but the exponents are the same, you just multiply the bases? Yes, and the exponent stays the same. All right, number 5. 2 to the x plus 2 to the x equals 2 to the x plus 1. This one is a very, very tricky one. My first instinct is to put false because we can't combine these. Do you agree? Okay. Well, I'm going to put a star by this one because this concept, you may think, oh, it's true, false. I'll need to really pay attention, but it comes up over and over what I'm about to show you. So you do need to make sure you're paying attention. Is everybody paying attention?
Yeah.
I'm going to use u substitution. I'm going to call this u and this u. What's u plus u?
2u.
Does everyone agree it's 2u? Okay, what was u to begin with? U was 2 to the, so I have 2 times 2 to the x. Okay, I'm going to pause there, and I know, I see a lot of what?
Sounds like witchcraft.
Okay.
It's
I'm going to put here u equal 2 to the x. Do you guys first and foremost agree that's what I did? I took 2 to the x out of the picture, and I put what in its place? U. And what's 1u plus 1u? Then I put this, and I put it back in. So this 2 to the x is, I took u out, and I put 2 to the x in. Okay, do you guys see that? Okay. Now, it's what's the power here that I don't see? And because the bases are the same, what can I do with the exponents? Add them, but the bases stay the? So it's 2 to the 1 plus x. True or false? True. Okay. Now, when you see this again, it will not be as a true false. I'll give you something like that and ask you just to simplify. And you would have to do all this work, and your final answer would be 2 to the 1 plus x. All right? So no, that's not the end for this problem. It does come up again. Let me show you one. This will be what you're going to see like come test day. Simplify. We'll call this number 6, but I put in a test bubble because it's not true false. All right, are you ready? 3 times 2 to the 2x plus 2 to the 2x. That's what you're going to see, and I'm going to ask you to simplify. Okay, what's popping out at you here? That these two are the same, so I'm going to call those what? U. All right, so I have, can you guys tell me what it looks like once I put U in the picture? 3U plus U, which ends up being 3U plus 1U is what? 4U. And this problem's for you. And what do I plug back in? All right, we plug this back in. 4 times 2 to the 2x. I know there's a lot to digest, guys, so I want you just making sure you at least understand every single step. Even if at this point you feel like there's no way I can do this on my own, as long as you understand every step, you'll eventually get to be able to do this on your own. So any confusion on any one of these steps. Now, in order to add exponents, the bases have to be the same. So what do we do with the 4? Change it to 2 squared times 2 to the 2x. Because the bases are the same, what can I do with the exponents? And the bases change to 4 or stays 2? 2 raised to the 2 plus 2x. That's what you would give me as an answer. That would be a typical test question. A test question. All right. Do I need to go over exponential growth and decay graphs with you guys?
Yes.
Yes?
100%.
Ask me your question, isn't it? Yes. Okay, yes. So I'm going to go through it quickly since you guys have seen this before. First, before I move on here, any questions up here?
No.
All right. X, Y. Y equals 2 to the x. I'm going to give you -2, -1, 0, 1, 2. You guys spend a whole lot of time with this last year. Graphing and shifting and translating and yada, yada, yada. All right. 2 raised to the -2nd power is not -4. It is 1/4. 2 raised to the -1st power, 1/2. And 2 raised to the 0 power is not 0, 1. 2 raised to the 1st is, and 2 squared is 4. Oh, this one here?
Yeah.
Thank you. Sorry for those of you that were writing with me. You guys said it, I repeated it, but for whatever reason my hand did not work. All right. -2 up 1/4. -2 up 1/2. 0, 1. 1, 2, and 2, 4. And did it ever touch across the x-axis? No, it got really, 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 really close, but it never touches or crosses. What is this called? Exponential growth or decay? Growth. Exponential growth. All right. What kind of bases do we have in order for it to be a growth? The numbers have to be bigger than 1. 3, 4, 5, 6, 7. They're all going to be growth. What type of bases do we have? Musa, take those glasses off, please. What kind of bases do we have in order for it to be a decay? Smaller than? What? But can they ever be negative? Should the bases be negative? No. So 1/2, 1/3, 1/4, 1/5. Those will be decays. So number 2, y equals 2 raised. I'm going to change it to this just in case you ever see it. What does 2 raised to the -x mean? What do you do with your base? Flip it. What's the reciprocal of 2? 1/2 raised to the x. Is that growth or decay? Okay, so I show you this way, so when you see it like this, kids will look and say, oh, 2 is bigger than 1, it's a growth. No, it is not. Because of that negative exponent, it flips it to a what? To a 1/2, which is a decay. Do you guys see that? Yes? All right, x, y, -2, -1, 0, 1, 2. Okay, when we plug in, do you want me to plug into this one, the 2 to the negative x, or the 1/2 to the x? 1/2? This, okay, well, you guys decide. I heard both answers. All right, do it quickly, whichever method you're using. When I plug it in this one, the negatives cancel, so it is just 2 squared, so it's 4. If I plug it in this one, it's 1/2 to the -2, and it flips it. Either way, what's the next number? 2, and then 1, 1/2, and then 1/4. All right, go ahead and graph.
Checking in for the kid will be gone for AdvMath.
Oh, for the AdvMath.
Yeah, for the BB.
What class? What class? What teacher do you do?
Miss Burns.
Okay. Okay. All right. Thank you for checking in. Chauncey, we're going to be reviewing, so just watch the video notes online. CWmath.com. Guys, listening. Did what?
He's not gonna remember that website.
Because it's so hard?
Yeah. Super duper hard.
I know, all those letters and numbers. Who would ever remember all that? And letters that don't mean anything. All right. Did anybody graph it already? -1, 2, 0, 1, 1, 1/2, and then this is an exponential growth or decay? Decay. Does it ever touch the x-axis? We call that an asymptote. Do you guys remember that? Exponential decay. All right. Questions? We're good?
Yeah.